Today I'm going to be discussing black holes. Black holes are ever present in sci-fi films like 1970's Black Hole and recently Interstellar. Black holes leave much open to speculation as we don't really know for definite anything about them, so they are very much open to interpretation when it comes to writing a plot for a Hollywood movie. But what scientifically do we think we know about them? What are black holes? In the 18th century, John Michell stressed the idea that there are regions of space where the force of gravity is so strong that not even light can escape it. He maintained that this was the result of a large amount of matter being compressed into a very small space to form a singularity, that being the point at the centre of the black hole. Since even light cannot escape, we wouldn't be able to see them, however we could feel their gravitational attraction, so we can conclude their whereabouts by the effect they have on nearby matter. How are black holes created? Most black holes are the result of the death of a star. The star is kept stable by the balance of two opposing forces, the outward pressure of the energy emitted by the star by fusion and the inward pressure of gravity, which is trying to collapse the star. If the force of the inward pressure of gravity is stronger than the outward force, the star would implode. Once the star starts to run out of the hydrogen needed for fusion, it will emit less energy than needed to counteract the gravitational force and the star implodes. This compression of matter results in a black hole. The event horizon. This is the point at which gravity is strong enough to pull light back. Since according to relativity nothing is faster than the speed of light, nothing would have the energy to drag itself outwards past this point. If you were to say move through the event horizon, you wouldn't notice. As gravity is so strong past the event horizon, you would be stretched as the other half of your body is still outside the horizon. This would result in you being stretched before ultimately ripping in two and being crushed inside the infinitely dense black hole. In 1974, Stephen Hawking discovered particles, which he named Hawking radiation, leaking out a black hole, and concluded that eventually the hole will shrink and lose mass as the particles leave. The particles leaving the hole, however, do not relate to what fell in and only have relevance to the mass and rotation of the object. This means information is lost, which counteracts the fundamental principles known in physics. Black holes have caused more questions than answers, and no one really knows much about them. From a new study called quantum gravity, by combining the theories of quantum mechanics and gravity, the singularity of the black hole is considered to be infinitely massive and infinitely dense with an infinite gravity. This is a breakdown in the laws of physics, as nothing can be infinite. The interesting thing here is this relates to the Big Bang theory, as we know that the universe is expanding, so it must have come from an infinitely small point, a singularity. By solving the idea of singularities in black holes, we could work out how the universe itself started.